this next speaker, amazing. First of all, we are so lucky to get this speaker. We had to wrestle this speaker away from so many other conferences. It was amazing. We have a list here of all the other conferences. We had to, so many other people wanted this. There was the conference, it was The Inner Peace and Yourself. They wanted him. Quiet Reflection, they wanted him. The Subtlety Conference, they wanted him too. Who else wanted this guy? Oh, I know what it was. The Quiet, Silent, Unassuming Conference. They wanted this guy, but we got him. We got him instead. We were able to grab this young man, and let me tell you, you won't be disappointed. Ladies and gentlemen, we are going to give you the man himself, the one, the only, the showstopper, the gift giver, the amazing Ken Wheeler.
What's going on, Kenneth?
What's up, man?
Oh,
how did we steal you away from the Silent Reflection Conference?
Well, Magnolia holds a special place in my heart. So I told them they're gonna have to wait silently.
Right. See, and we also, man, there was so many. The non-drinking conference wanted you.
I know, and I was gonna go.
I can't deal with you, man. I can wait. I mean, before I let you do your thing, tell me how you think about this. A talent show, bruh. If we hit the next live thing we have, let people show their talent. I don't like, maybe there's this amazing DJ dude who can do cool music stuff with their coding. What you think?
I think that sounds like a great idea.
Boom. That's it. It has been blessed by Ken. The Ken and Ken connection has decided this is gonna happen. Gonna happen. Drop knowledge, my brother. Drop the knowledge.
All right, let's share this screen here. All right. Oh, damn it. The Zoom thing's like hiding the I can't have a potty mouth on this. I know Kenneth doesn't like the potty mouth, so I'm gonna watch my mouth. Hey everybody. I'm Ken Wheeler, and this is doing the least amount of work possible. An intro to runtime performance. I'm not going to teach you how to do less actual work, though I probably could, but it's neither here nor there. So what's runtime performance? I would imagine most people know what I'm talking about, but if you don't, it's in contrast to load time performance. And it's how your app works while it's running, right? So most of the time you hear about performance on the web, or you're getting yelled at by folks from Google or what have you. They're talking about load time performance, right? You're going to see Lighthouse scores getting posted, and it's about how fast your website is actually loading. They have tools for this, like Lighthouse. They have the Core Web Vitals. You can tap into some of those things. They're concerned with the weight of your page overall, the weight of your JavaScript particularly, because it has to get parsed. Metrics like first contentful paint, time to interactive, which is the time until you can actually interact with the page. And I'm not saying that these aren't important. They are very important. But so is runtime performance. So essentially what I'm going to talk about today is, once you've gotten your TTI, once you've gotten your time to interactive, how do you stay interactive, right? How do you, keep it going and have a good running app that is fast and doesn't feel bad, right? So the cornerstone of staying interactive is not blocking the main thread, which is, depending on what you're building, harder in some cases than you would think. A lot of the time, right, if you have like a website that's just like a site that people are casually visiting, or if you have like e-commerce website, something like that, right? that load time performance is crucial, right? Because that is going to make people stay, number one. And number two, it's going to make people convert. Um, with runtime performance, right? A lot of the time it's like you're not, it's not a singular goal to go through and convert or stay on the page, like retention. It's like while people are there, you want them to have a good experience, something like an app, right? So the kind of issues that can arise are from things like computationally expensive tasks. Like if you're trying to do something particularly rowdy or loop over something or something like that. Animations and graphics updates. So like if you're like making a game or animating something, you can see that sort of issue there. One interesting one is reflow, repaint, and layout, right? So that's a lot of the time, you don't even need JavaScript to have that be the problem. You can do that on your own with CSS. And what that is if you're not familiar with reflow and repaint, so like Google Chrome, right? It draws your web page essentially using like Canvas, right? It's a graphics library called Skia, where it actually draws the page, and it has a layout algorithm that does the actual layout of the elements. So if something changes, right, an area of that screen will get invalidated, and you're going to have what's called a repaint, right, where it's going to go and the browser has to repaint that section, and then if that section's constantly getting invalidated, it's repaint city. As far as layout is concerned, on the web, your layout is largely relative. So you have 90 items on a page, number 36 gets a little bit bigger, everything around it now shifts as a result of that. So you need to recalculate layout, repaint, and that's called reflow. Also things like parsing, right? Like if you're taking a lot of data in really rapidly, you can lock the thread up by having to parse all that, especially if it's a larger piece of data. And the worst one ever is memory leaks. That can go one of two ways, and that's either it just crashes, or you sit there for half an hour and you get frog in the potted with it. You're sitting there clicking and it's getting progressively slower to the point where you're like, is this kind of slow? And then like 30 minutes later, it's like, close the page or keep waiting. And it's the worst to try and debug if it's not an event listener or something like that. So how do you know that you have a performance issue, right? The one worth solving, right? Nobody wants to prematurely optimize. So the best case scenario that you'd be in, the best case scenario you'd be in is you wouldn't even know it, and then that's kind of like a, do you have a performance problem sort of situation. But yeah, as far as like noticeable performance issues, the best case would be like you're dropping frames, or you have like an input delay, right? Where you go to like type into something on your page and it's kind of, it's not keeping up with the fingers. The worst case is you just get all snapped, right? Something is so wrong that it just, and that's really hard to debug because you can't even open DevTools or anything like that. So that's when I start doing binary debugging, basically deleting half my code until it goes away and you figure out what's going on. Because yeah, that's tough stuff. If you can't get into the DevTools or error logs or anything like that. So how do you fix it, right? If you have a performance issue, how do you fix that performance issue? So I can't sit here and tell you, here is exactly the steps to follow to solve all your performance issues, right? Because it's not prescriptive. It's like each performance issue is its own thing that's sort of personal to your code. And it's sort of like detective work, kind of figuring out like what is causing this. Sometimes you can know what's causing it, but then you have to get clever to actually fix it, right? Sometimes it's not even a bug, it's not even like you screwed something up, you have more throughput than you had necessarily imagined, you know, and now we have to figure out how do we make this run even with this amount of data, that sort of thing. But if I were to be prescriptive, there's a couple things. And the number one is to reduce iteration as much as possible. So if you can do what you do in 5 loops in 1 loop, do it in 1 loop, right? Because anytime you're iterating over large amounts of objects or right, you know, whatever's in the array, that's a hotbed for shenanigans. So in that kind of scenario, right, where you have a lot of items, using regular for loops actually helps a lot. You know, if you're at the point where that kind of performance minutia will benefit you, switching to a for loop is really, really fast, and worth a shot. Another thing is lookup tables, right? So if you have like a huge array and you want to find something in it, like array prototype find is like extraordinarily inefficient, especially if you're doing it in rapid succession or all the time or anything like that. So if you do need to get a piece of data out of an array really quickly, right, when you're building the array in the first place, right, you can just create an object that maps a key to an index or something like that, and then you have a very efficient shortcut right to that specific piece of data. Another thing is avoiding creating new objects, not only because you know, that's expensive in and of itself, but the garbage collector goes bananas over this. And I see a lot of like when you're doing like a object spread, that's creating a new object every single time. So in a scenario where you are trying to add things to an object and you think it's cute to do this object spread and then put them right then and there, if you have enough items, what's actually going to happen is the garbage collector is going to go bananas. So you can, you know, a lot of the time when I'm doing performance optimization, you know, I throw like this like pretty cool code out the window, and you can do mutation right then and there on the item. Which brings me to an interesting thing, perceived performance, right? So this is not even fixing things necessarily with code or math or, you know, optimizing iteration or anything like that. This is messing with people's minds. So a lot of the time, psychologically, people can think things are slow. So doing something like turning off animation can at least like perceptibly make it feel significantly faster. You know, like if you have a bunch of things, like a specific thing when you hover over, and if there's an animation or a fade or something like that, and you change that to be an instant feedback kind of interface event, people are gonna be like, wow, whatever you did, it feels really snappy. I promise you, it's unbelievable. So and there's a lot of things like that, like some of like the theory around loading spinners and things like that. You know, and like progress bars, like I forget what it was, but it's like 90% of progress bars are actually completely fake. But it'll keep people there, that sort of thing. So the psychological aspect should not be discounted. If you can avoid reflow and layouts, right? And that's kind of hard to, you know, preemptively do. But if you're going to animate anything, you know, usually using transform or opacity is a great way to do it, because that's not going to cause a relayout. Caching is another tool that you can use on the client side at runtime to reduce the amount of work that you're doing, right? The name of the talk, right? Doing less work. Ideally, what you want to do is your goal. You want to figure out, how can I get the functionality that I want, you know, achieve that goal while having my code do the least amount of work, right? Because then you can handle things. And especially if you can cap the scale, right? So for example, like a virtualized list, right? If you have a virtualized list, No matter how many things are in that list, if it can show 10, it'll show 10, right? So it'll only show 10 items, only ever render 10 elements there, and it'll shuffle through them as you go through the greater list. But what you're doing is you're capping the amount of things that are actually rendering there. So it doesn't matter if there's 25 things or 25,000 things, you have a known performance hit right there. And that helps with scaling. And the last thing is, there is quite a bit of sneaky minutia that you can look into and implement, right? It's a lot of it's like over optimization sort of, but if you really find yourself in a pinch, some of these things will help, right? If you're kind of grasping for performance draws, something like setting an object index to undefined instead of using its leak keyword is significantly faster. But like almost anything else in performance, doing things like that often come at a cost. So you might be able to make something much faster, but it is not free. The same thing applies to something like virtualization, where now you can handle any list length that you want, but now Control F doesn't work, or Apple F. So keep in mind, right? Like for every optimization that you make, there's usually some kind of trade-off, whether you're pushing it into CPU or you're pushing it into memory. You're with the object index to undefined thing. I guess if you do that, then the key is still present when you're doing like has own properties. Things like that, right? So be conscious of the difference when you're making those optimizations. But if you really want to figure out, you want to start investigating your performance issues, because that last list is kind of like general suggestions. But again, it's a case by case basis. So the only way to solve that is by profiling. Right? So in order to profile and develop your baseline in investigation of any performance issue, there's a couple tools that I recommend. That's the Chrome DevTools Performance tab. And that's where you're going to get like a timeline flame chart of kind of everything that's going on. You have the memory tab, which is where you can take snapshots of the heap memory at any given time. And then you can take subsequent snapshots and you can compare those back and sort them. And then you can see like what is rapidly allocating memory. And that helps identify memory leaks, which are pretty difficult to find in the first place. The performance monitor tool is outstanding as well, because that, unlike performance where you have to record it, the performance monitor gives you a real-time view of these things happening. So if you need to trigger it with an action, or have investigate as any kind of interactions taking place, you can do that. One of my favorite things that's part of the DevTools suite is user timings, right? So generally speaking, when you run your performance profile, you're going to see this flame chart of different things that are happening, but it's largely quantized. And if you're using anonymous functions, they're not named. So if you want to see very granularly, specifically, how long something takes, that's an outstanding way to do it, because outside of like having two timestamps and subtracting and console logging that, this actually puts it on the timeline for you, which is fantastic. And then if you are using React, the React profiler is outstanding, because if you have a React app and it's slow, most of the time you're unnecessarily rendering. You have more renders than you need, or you need to figure out a different way to render. But regardless, you're able to record, and it'll show you what is re-rendering, how many times, and most importantly, why. Because it's not always super clear why something is re-rendering. And that you're like, oh, what are you kidding me? Hooks again, am I right? The last one here is a little rowdy. So Chrome tracing lets you do like the performance tab flame chart profiling, but of the actual internals of Google Chrome while it's rendering your page. If you're in Chrome tracing, you're probably in trouble. You got a real problem on your hands. But it's helpful. So without further ado, I'd like to hop in and show folks how I use DevTools and certain things, because for me, when I started doing this, it wasn't immediately clear what all these things did or meant. And it's an extraordinarily powerful tool that if I show you, I think you'd derive value from it. Yeah, so we're gonna build a slow app, a real slow app. So right here's like a regular create React app type setup. All right, I'm gonna create a list of 500,000 things. And then I'm gonna do two things here that suck. So first of all, React State is pretty slow, generally speaking. I know there's like this ideology of throw everything in state, but don't do that. If it has no bearing on the re-rendering of the page or invalidating a hook dependency, it can be a ref, right? Like essentially I use refs the same way that you would use class instance variables like this kind of stuff when we had classes, and then it's not going to trigger or re-render unnecessarily. But state is pretty expensive, especially when you're setting like huge things and you're doing it often. The other thing that I'm going to do here is every 500 milliseconds, I'm going to update this state, and I'm going to clone the list here, right? With the spread business, it's pretty expensive. And then I'm going to go through each one and just change the value on it and then set the state, right? So I'll hit save here, and this is still going to spin, right? Because it's a transform, and that's fine. But if we come to our performance tab and we run a profile here, right, we can see some known shenanigans. So if you see red in here, that's not great. You don't want red in here. Red is bad. You can see here, these are, blockings, and it's going to show down here your total blocking time, right? So over the course of how long you recorded, this is how much time estimated was blocked. Right below here, you're going to see the performance monitor. And right here, right, we can see CPU usage, and that is 30%, pretty standard. Well, not standard, but that's pretty consistent 30% that you're seeing here. You'll see over here we have this guy right here, and it's scripting system. If there was like paint and layout, right, you'd see like purple and some other colors, but you're not seeing that here. This is your scripting. This thing back here is system. I think that's actually garbage collection. That little gray mountain you got back there. Pretty clouds. That's that's GC taking place. But in here, right, you can see all the different things that, here's the heap building up, cutting down, building up, cutting down, building up, cutting down. And on that cut down, you're seeing the garbage collection take place right there, right? That's how to read that graph. DOM nodes, event listeners, all staying flat for the most part, right? If you have like a pretty common kind of memory leak where you're not disposing of event listeners when unmounting, right? You're going to see this blah, 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 like building up over time. If you have some tough stuff going on CSS wise, you'd see layouts and these style recalcs going nuts. This is spinning, so you have that going, but it's not really that bad. So let's hop back up and take a look here, right? So this goes like top down. So we have for each one of these, right, we have a timer fired, which is our timer right there, and then you have a function call, and now you can click this. Whip, whip, whip. and it'll show you where it's coming in. You will actually see the timings here. See that? It's 600 milliseconds right there for this state set. Rough. Hold on, the zoom thing is blocking my view. What are you doing? Okay. Yeah, so and then you could take it further down, and it'll you go through all the React internal business here, go down, and then at the bottom, right, you're gonna see these anonymous functions running, and then you see these garbage collections, right, which is we're creating all those new objects, and it is rough. That's these garbage collections right here. So not great. So that's how this view works. I'll just show you memory real quick. So we can come here, right? And you see like the currently allocated memory. You've seen it jump between 110 and 2 something another. But you could take a snapshot like this. That's actually probably rough because 500,000 things, but what can you do? Come on, Chrome. You can do it. You can do it, buddy. Come on, big dog. While I'm waiting for that, I'm gonna show you user timings, right? So if we wanted to find out how long it takes to clone this list, right, what kind of hit we're taking, you can do a thing. You can use the performance API with performance.mark, right? And you can call it let's say the start, and then after it performance.mark, right? And we'll call it end. And then you do a thing called measure, right? So performance.measure, and then you'll name it, right? We'll name it like clony boy. And then you have your you see the argument signature there. You have measure, name, start, mark, end mark. So we have start and end. Just back to here for a second in our dev tools in your memory, right? So this shows a lot of like internal stuff, right? And then as you get down here, right, you'll probably see a little bit more specific things. But then you can sort by shallow or retained size and see like where we have a ton of things. And a cool thing to do is you can go here and you can look at these different ones. And if we did more, right, you can do objects allocated before snapshot. If we did another one, right, you could see more of those. Right? It's probably going to think about that for a second. But yeah, this is a great way to like analyze the two, see what number went up, and then that's how you have a memory leak. So I'm going to hit save on this one, hit refresh just because I don't know what the story is. If I come back here, oh, hey, whoa, here we go. Let's party. Let's go, profile. You can do it, bud. Blow. Oh, come on. Yeah, so here we have this timings thing. And, this is what I was talking about before with the first contentful paint and all that jazz. But yeah, right here, these are your user timings. So you zoom in here and we have Clony Boy, and it'll have your start and end one as well. But this will show you the span of exactly how long that took, which is pretty cool if you want to see granularly, right? Because it's not going to actually show that in here. It kind of like quantizes these together, does a little bit of averaging. So before I bounce, I'm going to fix this problem by commenting it out. And then I'm going to show you how you can do, how you can destroy your app with CSS. That's always fun. So this thing over here is rotating with a transform, right? So it's not really a problem. But if we change this, right, if we tried to animate height, that's like the worst thing you could possibly animate. So if we animate height, check this out. This thing's gonna go nuts. It's gonna be like doing a shuffle. Oh yeah, it's just kind of jumping like. So yeah, if we come over here, our dev tools, hit record, we're gonna see a different kind of bad profile, right? So we hop in here. Oh man. So wow, it's it's tough to even zoom in. That's how much shenanigans are taking place. Come on, you. There we go. Yeah. So that is some serious frame drop, and that's the jerking that you saw is frames getting dropped. And here you don't see any yellow because yellow is the scripting, right? No, the rendering and the painting constantly invalidating. You see your compositor, right, which is how the browser's drawing, right, is very busy. The GPU is very busy. So yeah, if you see a lot of purple and green, and it's not really, I mean, it could, I mean, JavaScript triggered thing, right? But you know, this is CSS or your page layout acting up for whatever reason. So that's a way to check into that. And if you want to check paints, you can look at some of these things. Whoop, like layers here, right? So you can come here and this layers, and you can turn it kind of sideways and say, what's going on here, right? And then you know, you can flash the paints and all that stuff and take a look. You have your paint count here, compositing reasons, secondary layer to house contents that can be scrolled. So yeah, you got, you know, paint profiling, yes, all this. So you can profile the style shenanigans as well. But yeah, that's all I have today. I hope that everybody has a better understanding of how DevTools works. And if you have any performance problems, go fix them and be the hero. Thanks so much, everybody.